Hello everyone, myself Kajal Singh and today I am giving the presentation on the topic of counter plots. This presentation is an introduction of plotting of counter map, sometimes called counter plots in MATLAB. So let me start from the introduction. Counterplots in MATLAB are used to visualize or represent the 3D data into the 2D data within a specific range of x and y values. And counterplots also helps to identifying the critical points like maxima, minima, saddle points, and it's also help to find the critical points where counter lines are close together or intersect. Counterplots is also help to plot the graph by using the commands counter, counter ref, and counter 3. And after this, so now we start counter plots. There are generally 8 useful commands in MATLAB. So the first command is counter, which is used to produce the counter map, and the other one is counter 3, which is used to produce the 3D counter map. And the next one is counter RF, which is used to produce the counter map with the filled lines. And the other one is easy counter F, which is used to produce the easy counter with the paid lines. And the next one is easy surface counter, which is used to produce the counter map with its surface easy count. And the next one is easy counter, which is used to produce the simple easy counter map. And the next one is surface C, which is used to produce the surface with the counter fill lines. And the other one is easy mesh C, which is used to produce the mesh with its counter map. So let me start from our first command, that is counter. To create a counter plot in MATLAB, you typically use the counter or counter f function, which allow you to specify the function, the range of xy values, and the counter label you want to display. So here is the code first, and here is an example of counter plots for x z is equals to x square plus y square. So let's we first declare the mesh grid of x for xy, and the range of x is -3 to 3 with the step size 0.21, and same with the y, the range of y is also from -3 to 3 with the step size of 0.1. And then after defining the declaring the mesh grid, we use to define the function which we want to plot. So the equation is z is equals to x square minus y square, and then after defining this we put a command, that is counter x y z, and this command used to display a graph like this. But if we want to increase the number of lines in the graph, so we can also put the put any digit, like 25, put a number if we want to increase a number of lines in the graph. So we increase the number of lines by putting the graph, by putting the 25, and the graph is observed like this. So let me start with another command, that is counter 3. It is a MATLAB function used to create the 3D counter plot. It is used to visualize function of two variables for the function x comma y comma z in a 3D space. It displays counter lines on a 3D grid where each counter represents a constant value of functions. So here is an example for an equation that z is equals to x square plus y square. So first we define or declare the mesh grid for the variable x comma y within the range of -3 to 3 with the step size 0.1. And then after this we defining an equation for which we want to create a plot. Then after this we apply a simple code or a command, that is counter 3 for plotting the graph. And then after running the code, we get this kind of graph. This is the 3D graph which is movable, but in this is a screenshot, so I can't able, so I can't move it. So this is the graph which we use to obtain. Let's start with another command, that is counter f. It is a MATLAB function used to create filled counter plots, also known as filled counter map. they fill the region between the counter line and the color with colors to represent the different counter labels. Here is an example with an equation z is equals to x square plus y square. So first we start after starting the code we used to define the mesh grid for a variable x comma y within a range of -3 to 3 with a step size of 0.1. And after this we are putting an equation, defining an equation which for which we want to plot the that is z is equals to x square minus y square. Then after that we put in command that is counter f, and then after running the code we used to get this kinds of plot. This is the counter line with colors. So let me start from the is counter. It simplifies the process of creating counter plot for symbolic expression, eliminating the need of numerical evaluation and enabling you to work directly with mathematical equations and variables. In this plot we can that make a plot of two. In this plot we can use the two variable functions without having to go through the defining the mesh grid and other such things. So here is an example that is z is equals to x square plus y square, and we simply using the command without defining the mesh grid. In the easy functions we just simply use the command. We are not there is no there is no need to defining the grid functions. And uh, and and this produce the same exactly same graph as the simple counter produce. So we can differentiate in such a way that in the simple counter we are used to defining the mesh grid, but here we are not used to define the mesh grid. So this is the only difference. So let me start with the is counter f. It is a MATLAB function that is the part of the symbolic math toolbox. It is used to create filled counterplots of symbolic expression. So here is an example for the equation z is equals to x square plus y square, and and this is the code for that plot. Is at counter f in the equation, and after applying this command we get this kind of a graph. And this graph is exactly same as the counter f as we already done. So we can differentiate between the both of these is that in the counter f we defining the mesh grid, but in the easy counter f we cannot define, we will not define the mesh grid. So due to this they both are different. And the other difference is also that in this easy counter it is easy to declare, but here we cannot alter the number of lines according to our wish, and also we cannot label the axis. So this is the drawback of this. So let me start with another command that is easy surface counter. The function allow you to work with symbolic mathematical expression and usually represent them in a 3D surface format. Making it useful for working with symbolic mathematical relationship and equation. And here is the code for that command. For the same equation we will plot that is z is equals to x square plus y square, and here is the command which we are uh, apply for to run this code. And after applying this command we got this kinds of graph. It is the graph in 3D which also can rotate. So this is the easy surface counter. So here it is the superimpose of the two counter. This one is the counter plots and this is the surface plot. These are the counter lines. So but there is a easy counter, it's easy to declare, but there is a one drawback also, that in this we cannot alter the number of lines. We cannot increase or decrease the number of lines according to our wish, and we cannot also label them. So this is the drawback. And here is another example for easy surface, where we take a equation z is equals to cos x by 2 minus sine y by 3. and after easy surface we apply the command, and after applying the command we got this kind of graph. This is also in 3D. We can move it, we can rotate it. So the last one is easy mesh C. So it is an typically used for visualizing three-dimensional data when you want to display a 3D mesh surface along with counter lines for symbolic expressions, eliminating the need of numerical evaluation and enabling you to work directly with the mathematical equations with an variable in MATLAB. So here is also again example for the same equation, and we again apply the command, and then after that we got this kind of equation. But here the same problem is in this also, that we are not using, we cannot alter the number of lines in easy commands, and we cannot also label them. So thank you for listening me.